Okay? So, you got dance teacher and money as the variables. So, again, what is a variable? A variable is something that can change. Right? Can the dance teacher change?
Yeah, you change art, yeah.
Well, in this situation, she can't change.
Right. She's not going to change in the situation. We don't have multiple dance teachers. But the other one you said was, what was the second variable you said? Money. Is money a variable? Could the amount of money Lakeisha makes change? It is. So I agree, money earned is one of the variables. What did you find the other variable to be? Hours worked. Okay, so you've got money earned and hours worked are the two things that can change. So those are the two variables. So now we've got to decide, is the money earned depending on how many hours she works?
Yes.
Or does the number of hours she works depend on how much money she has? It would be the first one. So the sentence here would be, the money made, or they use money earned. Money earned is a function of, and then hours worked. And I kind of ran out of space here, so I just underlined it. Money earned is a function of hours worked. Boy, hours worked looks terrible on there.
No.
Looks like
It looks
hours.
like
Looks like
It looks like hours work.
Yeah, let me try that again.
You need a couple hours of work to get.
That's better.
Oh, that is great.
It's better. Okay. Any questions on A? Okay, so because we said it like this, we should already know what's the independent and dependent variable. Right? Is a function of is just another way to say depends on. So if money depends on hours worked, then what is my independent variable? Hours worked would be independent. So you should have independent, money, and dependent is, I did it backwards, didn't I?
Yes, you did. You did say that. Yeah, you do it now. Do it now.
Independent is hours worked. Yeah, how about I broke that promise the next day? And dependent is money earned.
Funny.
You might need to go work at the Comedy Barn. You may have a future at the Comedy Barn. That's the laugh they use.
Killian makes my day better.
Oh, Lord.
Any questions on A or B? This should be a review. Because what have we been working on this whole unit?
Function.
Functions. Right, Maui? Functions. What's a function, Maui? It's a special kind of relation. Where?
How many outputs?
What kind of relation is it? A special relation where?
Only
Every
one
input has to take
input
one
has
output.
one output.
Every
Yeah.
input. All the inputs have exactly one output. Every input has exactly one output. Okay, so we're going to keep using that function again, and we're going to complete this table. So look, they got a table set up for us. Our independent variable is our x, number of hours worked. So depending on how many hours she works, we're going to then establish how much money she earned.
Wait.
Well, what was some interesting things about the hours worked? It says,
She started with $10.
so she's starting with $10.
Does that mean
Is that every hour?
that her 10?
Oh, never mind.
Go ahead.
Does that mean that she gets 10 plus 5 every hour?
No, she started with 10, then she gets 5 every hour.
Yes, that's what that means. So that's what we call like a flat fee or a flat rate. So like a lot of times, think of a situation.
So do we add on?
Used to be when you got a cell phone, you didn't have unlimited minutes to call. they used to give you like, I don't know, 200 minutes to talk on the phone in a month. And so, if you had 200 minutes, say that cost you $10. Then they would charge you a rate for every minute over 200 minutes. Say it was 10 cents per minute or whatever. So that's what we call like a flat rate. A lot of times, like photographers will have that. You have to pay the photographer $200 to come take your picture, and then you have to pay for every picture that you buy from them. Right? So there's a flat rate, plus then there is an additional rate on top of that. So this means what? She's going to start, she's giving her $10. Before she does anything, Miss Alvarez is giving her $10. Then she's going to give her $5 for every hour she works to keep her computer records current, but she will only pay for whole hours. So if she works 2 hours and 59 minutes, she's not getting that third hour. Right? You have to get all the way to 3 hours in order to get the next $5. So, when we complete the table, let's do that together. Okay? If she worked no hours, if Lakeisha worked no hours, how much money will she be making? $10. So basically, Miss Alvarez agreed to give her a $10 donation just for being such a sweetheart. Right, here's your $10. Let's go, Mallory. Let's go. Gotta look alive. I don't need you sleeping. Go ahead and put your Chromebook up. Move it. That way you can't lay on it. It's not a good pillow for you. Okay.
Get neck pain. Get neck pain.
Now, at the next data point, what if she worked for 1 hour?
$15.
She would get the $10 flat fee, and then she would get $5 for that 1 hour. So then 10 plus 5 is 15. You thought she got 10 for every hour. Is that what you're saying?
Well, that's what I was.
It's more understandable for the next one because it has more hours.
With these, do you understand what's going on? You think you can fill out the rest of the chart without me?
Yeah.
I'm going to give you a chance to try it. 2 minutes.
I already did.
2 minutes, fill out the chart. Overachievers. I'm going to have to start like restricting y'all's ability to work ahead. You get the last one. That's what I want you to think about. That's what we're working towards, right? And then we'll talk about what some of us are missing. So, if Lakeisha worked 4 hours, how much money would she have made?
30.
Okay, how did you come up with 30? Remember yesterday we had that whole column for a rule. It's not there anymore. How do you get 30? Go ahead, Tay.
I did 5N times.
Well, no, don't say that.
Oh.
How do you get to 30?
Oh,
30. 30.
4 hours.
4. So you did,
4 times 5, and then plus 2.
okay? So 4, the number of hours worked, times 5, and then added 10.
That don't make no sense.
Why not?
That don't make sense.
Why doesn't it?
Oh,
Hold on. Stop.
Well,
well, come on.
okay, look. So what I did. All right. So she had $15. Like when she worked 1 hour, she
Okay.
had $15.
Okay?
Okay. Then she worked 4 hours, and she gets $5 for every hour.
Uh-huh.
So then she had $20, but she already had that 15, so I added that 15.
Oh, no,
Okay.
no.
No. Here's why. How many more hours did she work from 1 to 4?
3 more.
So if you did 3 instead of 4, your logic would work. She didn't work 4 more hours. She worked 4 hours in total, which means there's only 3 more hours, which was just $15 more.
So why are we adding the 10? I thought we weren't doing that.
Because we should start over every time. We're going through different scenarios in every situation. So say, for instance, she worked for, 8 hours. How much money does she make for working those 8 hours? She's getting $5 for every hour, she does it 8 hours. So 5 times 8 is 40, plus she had a $10 flat rate at the beginning, which means she made a total of $50 if she worked 8 hours. So what was our rule we did there? We did 5 times the number of hours, and then we added 10. All right, let's look at 12. If she worked for 12 hours, how much money would she make? How do you get that? 5 times the number of hours, 12, which is 60, and then add 10, which is 70. Do I need to write that down? Or can you guys follow, Patrick, without me writing it down? I don't feel like we are. I feel like there's a few that are, there's a few that are just going with the flow.
I am the floor.
If I worked for 16 hours, I would do 5 times 16, which is 80, and add 10, which means it is $90 total that I've earned. If I worked for 20 hours, I would do 5 times 20 and add 10. So that would be 100 plus 10. That is $110.
That's not a good job.
So what's the pattern we have to do every time to find our money earned? 5 times the number of hours, and then we need to add that $10 flat fee. So what if she worked in hours? I would need to do 5 times the number of hours, which is in, and then I need to add 10. That's your formula. 5 times the number of hours plus 10. You guys see where that comes from? I saw a lot of 5 in, which means you're in the right ballpark. You're thinking about, all right, we're $5 for every hour, but you were leaving out this flat rate. So I was trying to ask you questions so you could realize, how can I get that $10 included? When I asked, some of you changed it to 10 in. All right? Then I saw some 10 in plus 5. All right? So, I mean, y'all are in the right headspace. But again, what I would do is think about, how did I find these values? What was my process? I did 5 times the number of hours, and then I added 10. Right? And that's all this is saying in words. 5 times the number of hours plus 10. That's the symbols. And I just said it in words. So now, just like yesterday, where we wrote a function rule, E, that gives money earned in, E that gives the money earned for n number of hours worked. Use function notation. So yesterday we had the f of x that we wrote as g sub 1 of n. Was n our other variable yesterday? Yeah, I think it was. And g sub 2 of n. You're going to do the same thing here, except we're not using g. We're using e for earn, right? Just money earned. So try to come up with a function rule for any amount of hours worked that tells me how much money was earned. So it's going to look like the f of x. I've seen some good-looking things. I've seen some not so good-looking things. Being able to write this in function notation is not going away, guys. So if you didn't learn it yesterday, you may need to think through it again today. So make sure you're paying attention. What does function notation normally look like? It normally looks like f of x equals something. That's your rule to how to find the number. But in this case, my variables are not f and x. What are my variables in this situation? E and n. Which one is the independent variable? Because we know x is normally our independent variable, the thing we get to choose. In this table, what did we get to choose?
Hours.
The hours worked. So instead of saying x, We need to say hours worked, which is given by N. So in parentheses, we should have an N.
So I just had it backwards?
And then what is that representing? The F represents our output or our money earned. So in this case, instead of saying F, we're going to say E. So this is capital E of lowercase n, right? E of n. Are there any questions about how to come up with this part? I'll say about 70% of people had this. All right, some people had E of 5. I'm not sure exactly where y'all's 5 came from. I think it's because maybe it was $5 per hour. Is that why y'all thought 5? Okay, that's not where the 5 shows up. The 5 will show up in your rule. So what was the rule we used to figure out how much money was earned for every n hours? It's the rule we came up with at the very end.
5 times n plus 10.
No matter what n is, we can do 5 times that n, add 10 to find how much money she made. So the rule to find how much money was made is 5 times n plus 10. This is function notation using a rule. So now, pick any n you want, because that's why it's independent. What n do we want to find out? If she worked how many hours?
73.
If she worked 73 hours, then what would that look like if I worked that out with algebra? That would be E of 73 equals 5 times 73 plus 10. Right, that's what we decided to do. 5 times the number of hours plus 10. 5 times 73, that's going to be 365. 365 plus 10 is 375.
Yep.
Thank you.
What she worked.
So E of 73 is 375. Is this what they ask us? No, but I'm trying to show you where we're going. Okay, we're building the bare bones of it in order to use it in this situation tomorrow. Okay, that's where we're going next. Did yesterday. So if I ask you, what does E of 7 represent?
I got you.
Go ahead.
The amount of money earned in 7 hours.
So the 7 in parentheses tells you how many hours have been worked, and the E represents the earnings. So if I ask you what is E of 7, what I'm really asking you is, how much money did you make for working 7 hours? Right? That's what's being asked. So if I had to write that in words, I'm going to write down exactly what they have. So that way you know it's good. So this is what they said. They said the money Lakeisha earns.
Ooh, big word.
And I guess that's true. So one thing you're going to see a lot of the times, whenever I work out a problem, I always put myself in that situation. I never care if it's Lakeisha or Carl or Oswald. All right, I don't care who it is. I always just talk about it being me. So that's probably a mistake. I'll make a bunch. It's the money Lakeisha earns for working 7 hours. So again, what are the big steps there? It represents money earned for working 7 hours. Right? That's the part that I care about. Whether you say Lakeisha or not, whatever, I don't care. Okay, but you got to understand the context of what's going on. And then what was the value? What does E of 7 evaluate to be?
45.
It is 45. So I would also want to see somewhere E of 7 equals 45. And again, how did we get that? Well, we did 5 times 7 plus 10, right? 5 times the number of hours plus 10. We just plugged 7 in to our original equation.
On part F, how are we going to do things that are not possible?
Okay? So I saw some good things. I saw some that were struggling a little bit. Let's talk about it as a group. What were 3 possible input values that were not on the table but you could use?
40, 30, 40, 45.
So 30, I heard 30, 44, 40, 24.
69.
Okay, so all those, I agree, those are possible number of hours that we could work. What are some things that are not possible for working?
7.5.
Okay, so I'm hearing different things. Let's do one at a time. Okay, so I heard 1.5. So why is 1.5 not possible?
She only pays for whole hours.
She only pays for whole hours. She doesn't pay for parts of hours. So 1.5 is not a valid input because that's counting for part of an hour. We're only counting whole hours. So 1.5 would not be any good. Negative 16. Why is negative 16 not valid? Can she work negative hours? No. So any negative number would be not possible.
Negative 3.7.
Negative 3.7, that's got both problems. 1/4, right? So a fraction, right? Again, that's again part. I heard Trenton said 10 minutes. So if you put the unit 10 minutes, that wouldn't be possible either, right? Because 10 minutes is part of an hour.
Like, if you do negative, could she still be getting $10 out of that?
No, because it would go away.
She would get $5.
If you plugged it in, it would go away. The negative hours would make the plus 10 go away. Like if you plug in negative 1, 5 times negative 1 is negative 5. And 5 plus 10 is 5. If you put in negative 1, she'd only get 5. So it doesn't make sense. Because she's starting with 10 no matter what. Okay, are there any other values that seem outrageous that you could put in? So we've established negative numbers are no good. We established fractions are no good. There's integers are good. But what about, how long is she working for? How long? Like how long is she working for Miss Alvarez?
Hours.
No.
20 hours.
Read it. Read the problem. See what it says. Miss Alvarez will pay her starting amount 10 for every $5 she works. Oh, it doesn't say up there. Okay, so on my list, it says that she was able to only do this for 1 week. Right? She's only keeping computer records for 1 week. So, how many hours are in 1 week? 24 times 7.
So she could not work
168.
700
168. So she couldn't work like 200 hours in a week. Or she couldn't work 8,000 or a year.
1 billion.
Right? So you can have numbers that are way too big that are unreasonable for her to work as well. Okay? Good. Questions there? Yeah, I'm listening. Okay, so now let's look at G. On the coordinate plane, we're going to sketch a graph of the function, and we're going to label each of the axes. So I always start with labeling multiple axes or axes. If you have more than one axis. That's like, you know, if you have 2 of those number cubes that have 1 through 6 on them and you roll them, they're called dice. But if you have one of them, it's just a die. It's not dice. Cactuses, cacti, funguses, fungi. Yeah, I don't know what that one is, plural, but it sounds right to me. Okay. So here we're going to label each axis. So my x-axis, what does that represent? That's my input or my independent variable. It's going to be hours worked. So the independent variable is the number of hours worked. Yeah, you knew that. And then the y-axis, up and down, it's the amount of money earned. And so again, when I have to make a graph like this, I always like to try to make my points be on crosshairs because it just makes it easier to graph if I can. So look, my number of hours worked, what does each tick mark represent? 2, right? We're going up by 2. 2, 4, 6, 8. So let's just start at the beginning. If Lakeisha worked no hours, how much money would she have earned? 10. So I should go to 0, 10. On the y-axis, each tick mark is worth $10. Right? So for no hours worked, she made $10. If I go to the next one, for 2 hours worked, she's making 2 times 5 is 10, plus 10 is 20. So at 2 hours, she's making $20. At 4 hours, she's making $30. At 6 hours, she's making $40. What do you notice about these points? They're going up in a line, right? This is what we call a linear function, because every input has exactly one output, and it's going up in a line. That's a linear function. So I don't even have to really think about the rest of them. I can just kind of fill it out. Once you find the pattern for a linear function, just keep going with the pattern. And just go back and double check, make sure it makes sense. I'm saying if she worked 20 hours, she should have made $110. 20 times 5 is 10, plus 10's, 20 times 5 is 100. 100 plus 10 is 110. So yeah, there we go. Now the last question says, should I connect all these points to make it a line, or should I leave them disconnected?
You should connect them.
Okay, why should we connect them?
Because it's endless.
Okay, so this is where it's a little confusing. When you say it's endless, I think I know what you mean. That even though the graph ends here, these points would keep continuing up. That's true.
If she continued pushing.
If she continued working. But a line means more than that. A line, when I draw a line means every point between this red point and this red point should count. So let's see. Are there any points between, this is 0 hours worked and 2 hours worked? Is there anything I could put between them?
Yeah.
What would it be?
1 hour.
1 hour worked. How much would she make for 1 hour worked? 15. So there is another point at 115. Are there any other points between 0 and 2? Now they're all decimals, right? Half. Well, can I have half worked for her? No. So this is an example where we shouldn't connect it as a line because the values are limited. If you connect them, you're saying every value between here and here will work. So you would need for her to include parts of hours that she's not including. Okay? Does that make sense to everybody why you don't connect them?